In this video, I'm going to take a look at finding the surface area of one pyramid and then finding the surface area of a cone. First one's going to be my pyramid. And then I'm going to take that same approach that I do in many cases when looking at surface areas. I'm going to draw the net. Now I look at this one and it wants the surface area of a right regular pyramid. Now this is an important word in here. So is this. But the regular tells me that the base is a regular polygon. Therefore, when I look at that, well, if it's regular and it's a quadrilateral, it has to be a square. So I know we have a square base. And now, being that it's a right pyramid, that means that essentially if I were to take the apex of my pyramid up here and drop it directly down, it's going to hit the center of my square, which then means all the triangles on my pyramid are going to be congruent. Which makes it nice because now if I can find the area of one of the triangles, I just have to multiply it by 4 for all of them. And then I'm going to put in my dimensions. I know that my square is 6 by 6, and I know that the height of this pyramid is 4. Well, I'm going to need the height of the triangle eventually to find the area of it. Now be careful here because a lot of times people will want to say that the height of the triangle is equal to the height of the pyramid, and that's not true. That green dashed segment that I just drew in on my pyramid actually lies right here, which if you remember back to the vocab, that is the slant height. Now what I'm going to do is I'm going to connect the bottom of the slant height, the way I have this orientated, with the bottom of my height. And then what you notice is I have a right triangle there when you go from blue to black to green. I know the black segment is 4. I don't know the green. That's what I really need. And this blue segment here, well, being the bottom of the height is hitting the center of the square, that blue segment is going to be half the length of one of the sides, so it's going to be 3. Now I have a right triangle. I know that one side's 3, one side's 4, and I'm looking for the hypotenuse. So I can use my Pythagorean theorem. I can go with 3 squared, or a squared, plus now my b, which is kind of that brownish color. Just use the black, so that's 4 squared, and then equal to c squared, that's my slant height. I'm going to put L for the slant height squared. Solve my equation here, and I'll have it. We have 9 plus 16 is 25. So 25 is equal to the slant height squared. We take the square root of both sides, we find out that our slant height is 5. This part right here is 5, so when I come back over here, I know that's 5. Now when I look at my net, I just need to find the area of all the pieces. Well, the square is going to be 6 times 6 for a grand total of 36. My triangles, I'll do 1/2 times base, well the base is 6, and I just found out that the height is 5, so that's going to give me a total of 15 for the area of that triangle as well as every triangle. And now I can just add everything up. So I'm going to take my 36 plus, and I'm going to do 4 times 15 because there are 4 triangles and they all have, excuse me, an area of 15. So really I have 36 plus 60 gives me a grand total of 96, and I just have to make sure that I get the right label. I come up here and I look at this and it doesn't give me any labels or any units, so I'm just going to go with 96 square units, or units squared would be the surface area of my pyramid. Now not all pyramids are going to have 4 triangles that are all congruent, so keep that in mind. So sometimes the triangles will be different shape, and you'll have to find the area of all 4 of them. And in my next one, now this one I want the surface area of the right cone. And remember, we need that formula that told us that the surface area of a cone is equal to pi r squared, there's the circular base, plus pi r L, and there's your slant height. Well, I look at this and I go, I know my slant height, so I can plug that in, that's 26. Problem is, I don't know what the radius is, so I'm going to have to figure that out. And I'm going to draw in my radius. That radius, one place I could draw it in would be right there. And the reason I put it there is because now that makes a right triangle. I can use the Pythagorean theorem again to figure out how long this radius is. So I'm going to go with A squared plus my B would be the 24. That's the height of the cone squared, and it's going to equal slant height, or C, squared. Now I just have to go through and I have to solve that equation. I see I have a little mistake here. I said 24, I believe, but I wrote down 26 for some reason. Fix that. There's the equation that I should have. Now when I solve it, I'm going to have r squared. 24 squared is 576, equal to 26 squared, which is 676. I get rid of the 576 from both sides. I find out that r squared is equal to 100. Got to take the square root of both sides. I find out that r is going to equal to, remember, take the square root in the equation, you got to look at the positive and the negative. Positive or negative 10. Now, being that we're looking at the length of the radius here, the negative answer isn't going to make sense, which means that the radius for my cylinder is going to be 10, and look up here, inches. Find the surface area. So now that I have the radius, I can take that. Actually, I'm just going to take this and move it. I know that my radius is 10 inches. I'm going to take that and I'm going to put it in everywhere I see r. I just found out that the radius is 10. I found out that the radius is 10. Still have my pi. Plus pi times radius times slant height. So now I have 10 pi plus 260 pi. Oops, I forgot my square here. Thanks for telling me. Should have been squared there. So that's not 10 pi. That's going to be 100 pi. And then 100 pi plus 260 pi would put us at 360 pi inches squared. There's the exact answer. And now I know sometimes we want to have that approximate value as well. So after typing on your calculator, you're going to find out that the approximate value is going to be 1,130.97 inches squared. I like the exact answer because I could do it all in my head and I didn't need my calculator, but sometimes we do need that approximate value as well. So you have the surface area now of that cone using the formula and using a little Pythagorean theorem there as well. And then that's going to conclude my examples on surface area of pyramids and cones.